Alright, introduction, seepage and drainage, J.P. Geyer. Alright, introduction. Introduction, seepage analysis, seepage control by cutoff, design drainage blanket and filters, well point systems, deep wells, lining them for reservoirs and pollution control facilities, erosion control, and references. This publication is adopted from the Unified Facility Criteria Government Public Domain, have authorized unlimited distribution or not copyrighted. Our introduction. This publication covers the surface erosion analysis, flow of the quantity of the groundwater pressures associated with under seepage requirements are given with the method of the drain and pressure relief. Control of soil erosion must be considered with all new construction projects. Seepage pressures are primary importance of stability analysis and foundation design construction. Frequently drawdown of groundwater necessary for the construction, otherwise situational pressure relief incorporated with a temporary permanent structure. For erosion analysis, surface water flow characteristics, soil type, slope are needed. For analysis of the major seepage problems, determine the permeability of the pipe, piezometric levels, field observation. Alright, 2. Seepage analysis, flow net. Figure 1 shows the example of the flow net construction used for the procedure of the estimate of the seepage of the quantity with the distribution of the pore water pressures in two-dimensional flow. Flow nets are applicable to study cutoff walls, well points, or other shallow drainage. Inspection placed with a regular rectangular layout whose length is a plan and several times its width. Flow nets can also be used to elevate concentration of flow lines. 2-1 ground water pressure. For steady state of flow, water pressure depending on the ratio to mean permeability of the separated strata, the anisotropy of the layers. Carefully drawn flow is necessary to determine the piezometric levels within the flow of the field and position of the drawdown curve. Alright, shows a flow net, cut-off sheet, pipe well, fill, free water, equal vertical system, impervious base, previous stratum, aquadium, equal point line, discharge drainage layers, dock. This shows a transfer condition interface between statual permeable layer. K1 over K2 is equal to tangent over tangent B over tangent A. If straight squares are required, drawn in stadium ratio L over 8, and L over B in stadium 2 is equal to K over 1. Alright, rules for flow net construction. When materials are isotropic to the respective permeability of the pattern of the flow lines, equal point potentials intersect with the right angle with the draw of the pattern, which the square figures are formed between the flow lines and equal potentials. Usually it is expedient to start with the integral number of the equal potential drops, dividing with a head by a whole number to drawing with the flow lines with the form. These equal potentials in general K for the outer flow of the path of the width form of the rectangular rather than square figure. These shapes of the rectangular's ratio B over L must be constant. The upper boundary of the flow that is atmospheric pressure of the free water surface of integral equal potentials intersect free water surface tab of the point space of the equal vertical intervals. A discharge phase throughout the water throughout which seepage passes in the equal potential with a line if the discharge is submerged, or free water surface if the discharge is not submerged. It's a free water surface. If it is a free water surface, the flow net figures adjoining with the discharge face will not be squares. In saturated soil profile, where ratio permeability of layers exceed with the time of the flow of the meter, the flow of the more permeable layer controls that is the flow net may be drawn with the more permeable layers, assuming the less permeable layer to be the impervious. The head of the interface for the obtained within is imposed on the less pervious layer of the construction flow net within it. In a stratified soil profile where ratio permeability layers is less than 10, flows deflected with the interface for the inner corner of the diagram shown above. When the materials are antistropic with respect to the permeability, the cross section may be transformed by changing scale, as shown above in the flow net of the drawings of the isotropic material of the computing quantity of the seepage. So the differential head is not altered for transformation. Where only quantity of seepage is to be determined, the approximate flow of the net suffices, and as more pore pressure are determined to be the flow net must be accurate. Alright, 212, seepage quantity. Total seepage computed with the flow of the net depends permanently over the differential head of the mean with the permeability of the most previous layer of the ratio permeability of the separate strata of the antistropy has been influenced the ratio of the NF over ND in Figure 1 using ranges between 1 2 and 1.5 to 2/3. Thus, estimating seepage quantity of the rough drawn flow of the net provides reasonable, accurate estimate in total flow. Certainties in the permeability values are much greater than limitations of the accuracy. For a special case of flow regime, it can be analyzed with an finite element method. Mathematical expressions for flow are written for each element, considering the boundary conditions of the resulting system with equations solved by the computer output of the flow pattern. Alright, seepage force. The flow of the water soil exerts the force in soil with the call of the seepage force. The seepage pressure is the force per unit of volume of soil is equal to the hydraulic gradient times the unit weight of the water. So you have your seepage pressure is equal to hydrant gradient times times the unit weight of the water. The seepage pressure acts as the direction right angle with the equal potential line. See Figure 1. Seepage pressure is of the great importance of the analysis of the stability of the excavation and slopes because it's responsible for the phenomenon known as boiling or piping. Boiling. Boiling occurs when seepage pressure is upward direction exceeds the downward force of the soil. The condition can be expressed in terms of the critical hydrant gradient. Minimum factor of safety of the two is usually required. You have your actual hydraulic gradient, C, times actual hydraulic critical is equal to total unit weight of soil minus the unit weight of water divided by the unit weight of water is equal to the buoyancy unit weight of soil divided by the unit weight of water. Or your piping subsurface erosion. Most piping failures are caused with the subsurface erosion beneath the dam, but the failures can occur over several months, even years after the dam is laid for the operation. Essence of water that comes out of the ground and toast out of the process of erosion. The existing gradient is high enough that culminates with the formation of the tunnel-shaped passages beneath the structure of the passage. Finally, flows works down backward to meet the free water. The mixture of the soil and the water rushes through the passage, undermining the structure and flooding channel below the dam that has been shown. The danger of piping failure due to the subsurface erosion increase with the decreasing gain side of the similar subsurface erosion problems can occur with the relief, dry dock, the water seeping into the free surface source to drainage a filled blanket beneath the floor and behind the walls. If the filter fails, if the effect of the hydraulic gradients are critical, serious concentration of the flow must result in large voids erode channels. Potential passageway for initiation of piping include uniformly graded gravel deposit with the commonly graded open joints, bedrock cracks caused by earthquakes and crustal movements, open joints and pipelines, hydraulic fractures, open voids and coarse boulder drains, including French drains, abandoned well points, gulfer hills, cavities formed in levee foundations by rooting roots, buried wood, improper backfilling of the pipeline with anti-seepage collars, etc. Failure may be the pipe required with the progressive movement of the soil particles to a free exit surface that can be controlled with adequately designed filters for the relief blanket. Guidelines for preventing piping beneath the dams may be found in the reference 1, Security for Under Seepage over the Masonry Dams of Earth Foundations by Lee. Alright, 3. Your seepage control by cutoff. Method. The procedure for the seepage control conclude with the cutoff walls with the degree of the seepage decline with the reducing the existing gradient with the drainage of the relief structure that increases the flow of the quantity by reducing seepage pressure with the cutoff of the drawdown with the critical area. See Table 1. Sheet piling. A driven line of interlocking steel sheeting may be authorized for use in cutoff construction expedient as a part of the completed structure. Applicability of the following consideration governed for use in sheet piling. And then that's, you got your method, applicability, and character and requirements. Alright, that's rather lengthy. Alright, 3211 cheating, and particularly with a suitable with a coarse grain material with a maximum size of less than 6 inches with a saturated with a subsoil with the alternate fine grain and previous layer with the horizontal permeability greatly exceed the vertical. To be effective, sheeting must be carefully driven with the interlocks inactive with the bulge with buried obstruction almost certain with the damage of sheeting and the breaking of the interlock connections. Water tightness cannot be assumed if the obstructions are present. Loss head across the straight wall of the intact with the sheeting with it depends on the water tightness relative to the permeability of the surrounding soil. With the homogeneous fine grained soil has been created with the sheeting with the maybe is insignificant if the previous sand and gravel the head loss with the substantial depend on the extent of which of the path is lengthened by the sheeting and indicate the quantity of the water passing through the inner-tack interlocks may be as much as 1/10 of a gallon per minute per foot, with the wall length for each 10 feet. The differential added across sheeting, unless special measures are taken with this interlock. Preparation required. Paragraph 323 with the below apply with the equality and perfect wall of the listing table of 1. Seepage panel beneath the sheet driven for a partial cutoff may be removed with the piping dense sands or heavy loose sands. The heave occurs with the uplift or sheeting toe exceeded the submerged weight with the overlying soil column. To prevent piping and having the excavation carry below groundwater, sheeting must be penetrated with a sufficient depth of the subgrade with a supplementary drain. It will be required to subgrade with the figure 2. Reference to the model experience. It's a study of the influence seepage on stability of the sheet of excavation and sand by Miller's land. For sheet preparation, required with the various safety factors against the heave of the piping with the isotropic sand with the homogeneous anisotropic sands. Reduce the horizontal cross-section dimension of the transformation factor of figure 1 to obtain the equivalent cross-section with the isotropic condition. See figure 3 reference to for the sheeting preparation required. Layered subsoils for clean sand exit gradients of 0.5 to 0.75 will cause unstable conditions with the benefit of the equipment operating for the subgrade void, providing sheet penetration for the safety factor of 1.5 to 2 against piping heave. Supplementary measuring is uneconomical or impractical. Required sheeting penetration seepage for the existence of the gradients that may be reduced as follows for homogeneous materials or soils where permeability decreases with the depth of the voids of the well points, pumping wells, sumps with the excavation well points and pumping well with the well outside of the excavation are effective within some cases but do not interfere with the bracing and excavation. For materials whose permeability increases with the depth, for ordinary relief well with a collector pipe with its upgrade may soften permeous berm, a pervious berm, placed against the sheeting of the filter blanket with a subgrade will provide the weight of the balance unlifted pressure. Material placed directly on the subgrade should meet the filter criteria for the sheeting of the particular suitable to the cross grain with the material the maximum size less than 6 inches stratified subsoils with the alternating grain and pervious layers with the horizontal permeability gradient exceeds the vertical. Then it shows a chart of the preparation cutoff wall prevention piping isotropic sands, followed by a penetration cutoff wall required preventing piping and stratified sands. Followed by a penetration cutoff wall required for the preventing piping of the stratified sands. Alright, 324. On the outside open water surface may be blanked with a fine with a petanite jumped through the water of the place and then slur. As the slurry evaluate the effectiveness of these measures with the flow and that analysis ground cutoff. Complete ground cutoff frequently the difficulty costly attaining success for the grouting required with a careful evaluation of previous strata for the selection of the appropriate grow out mix and perceive the technique of the combination with the other cutoff drainage methods are particularly useful as construction is expedient with the control local seepage. Impervious soil barriers, backfilling, cutting off the trench when selected with impervious material with the placing impervious fill with the magma core with the routine procedures either earth dams. Compacted impervious fills of the properly constructed these section permit the negligible seepage compared with the flow of the foundation abutment. The previous layers lens of the compacted cutoff must be avoided by blending of the burrow materials, scarifying the bond of successful lifts. Mixed in place pile with overlap at the mixed in place pile with the cement with the natural soil forms of the cofferdam with the shores resistance around the excavation slurry filled trench. Concurrent with the excavation with the straight side of the trench with the backfilling with the slurry bentonite with the natural soil is done alternately with the cement with the bentonite mix can be used with the narrow trench with the carrier coarser gravel occurs insert with the case of the tremes concrete may be placed working upward the base of the slurry filled with the trench with a permanent peripheral wall. For design of the blanket of the filters water flows in the silt of the gravel. The silt will wash interstices of the gravel that could leave the following, which may include, which must be avoided. Loss of the silt may continue with the cause creating of the cavity. The silt may clog the gravel, stopping the flow of the causing hydrostatic pressure buildup. The purpose of the filters allow the water to pass freely across the interface. Filter must course enough to avoid head loss, but significant sufficient time. Fine to prevent mitigation of the fines of the filter particles must be durable and certain crushed limestones may dissolve. Filter requirements apply to all permanent subdrainage substructures in contact with the soil, including wells. See figure 4 with the protective filter design criteria. And then it shows a design criteria for protective filters. And then another one for continued. Filter may be too fine grained to convey enough water to provide good working with the surface of the path of the water freely without loss of the fines of the subdrain pipe. For this condition, the second filter layer is placed for the first filter layer. First filter layer is then considered for the soil for the protection for the second filter layer is designed on the finest filter soil, but often on the base for the coarser layers above. This is referred to as reverse inverted filters. Convert concrete, sand, ASTM C33 specification concrete aggregate softens with the filter against the majority of the fine-grained soils and silty and clay-like sands for non-plastic silt varied silt clay with sand silt lenses and asphalt sand ASTM D1073 specification fine aggregates bituminous pavement mixtures. Also, with a check of the criteria figure 4, local availability natural materials usually more economically perceived material that should be used with the meter filter criteria. Fine filter layer can be replaced with a plastic filter cloth under the following conditions. After reference 3, plastic performance of plastic filter cloth, the replacement with the granular materials and by Colin, etc. No woven filter cloth. The woven filter cloths with less than 4% open areas should be not used where silt presents sandy soils. The cloth with equivalent opening size equal to the number 30 sleeve and opening with the area with 36% will retain sands containing silt. When stones are dropped directly on the cloth or uplift the pressure of the artesian water may be encountered with the minimum tensile strength of the ASTM D1682 with the test of the break load, elongation of textile fabrics, and strongest wear direction should not be less than 350 to 200 pounds respectively. Elongating the failure should not exceed 35% of the minimum burst strength, should not exceed 520 psi. ASTM D751 testing coated fabrics. When the cloths are used in an application not requiring the high strength with abrasion resistant, the strength requirement must be may be relaxed. Hard cloths made of polyprene. Polyvinyl chloride and polyethanol fibers do not deteriorate under most conditions. They are affected by sunlight and should be protected from the sun. Materials should be durable against the ground, pollutants, insect attack, and penetration of burrowing animals. Where filters are caused for the use of the wrap of the collection of the pipe, then a similar application of the backfill should consider the clean sands, gravel grade across, such as the D85 with the grader with the EOS with the cloth with the end. When the trenches are lined with the filter cloth with the collection pipe, it should be separated from the cloth by at least 6 inches of the granular material. Cloth should be made with the monofilament yarns. The absorption of the cloth should not exceed 1% with the produced possibility of the fiber swelling with the changing of the EOS percent of the open area with the further guidance of the type of the property of the filter fabrics. Reference 4, construction geotextile engineering using synthetic fibers by Corin and Welsh. Drainage blanket. Figure 5 shows the typical filter drainage blanket insulation permeability. Reference 6 and Reference 5 of the subsurface of the drainage for the highways by Barber, given the typical efficiency, the permeability of the clean and the coarse grain drainage material, the effect of the various percentage of the lines of the permeability. Mixture of about equal parts of the gravel made to coarse sand with a permeability be approximately 1 foot per minute. With a single-sized clean gravel of the permeability exceeds 55 feet per minute. With the approximately with the relationship of the permeability versus effective the size of the D plus 10, see figure 1, chapter 3. Drainage capacity equal estimated with the quantity of water transmitted with the drainage blanket is as follows, and that is Q equals KI times A, or quantity of flow in feet cubed seconds is equal to permeability coefficient in feet and seconds times average gradient flow direction by feet and cross-sectional area by feet squared. The gradient is living up pressure that must be tiled over the point farthest from the outlet of the drainage blanket with the increase of the gradient of the flow capacity of the blanket, proving the closure space of the drainage pipes within the blanket. 4221 pressure relief. The sum of the bottom figure 7 the reference 6 for the seep of the requirement of the filter previous basis of the cedar grain. Through the combination of the drain piping spacing of the drainage course thick for the permanently required to control the flow upward with the underlying aquifer under the average vertical gradient of 0.4. Radius of the drainage. See the top panel, figure 7 of the reference 5 of the time rates of the drainage water of the saturated base of the course of beneath of the paving, the effect of the porosity of the volume of the drainage water and unit volume in soil. It ranges from 25% of the uniform material, such as the medium of the coarse sand, with up to 15% for broadly graded sand gravel mixture. Drainage blanket design. The following guidelines should be used and followed. The gradation design according to the figure 4, with the thickness beneath the structure required with the minimum 12 inches for each layer, with the minimum thickness of 24-inch thickness overall. It is placed on wet, yielding uneven excavation sources with the subject with the corrosion operating with a traffic minimum thickness of the bush shall be 36 inches overall. And then it shows a picture of your typical filter drainage blanket applications, and then your permeability capillary drain material charts, and then another analysis drainage layer performance. Alright, chemical clogging. Filter systems. Filter layers and fabrics and pipes can become chemically clogged with ferruginous iron carbonate deposits of the incrustations, where a permanent subdrain system is accessible. The pipe of a large perforation, 3/8 of an inch, increase the thickness of the filter layer that can be used for existing facilities. A weak solution with a hydrochloric acid could be used to dissolve the carbonates. Intercepting drains consist of a shallow trench with the collector pipe with the rounding by the drain material with the place with the intercepting seepage removed within the horizontally with the upper and previous stratum. Design the proper control drain with determined with the drain drawdown flow of the drains by flow of the net analysis. Figure 8 show the typical placement of the intercepting drain for the roadways of the slope. Shallow drains of the pond area of the drains consisting of the shallow stone with the trench for the collector pipes. So these should be with the collect with the control of the surface runoff. C with the figure 9. Reference 7 and C with the 2 with the ditches with the runoff plain water table overlying with the gravel substratum by Kellerham, and the reference 8 with the seepage of the ditches within the cave with the plain water table impervious stratum substratum of the Kirkham. For the determination of the rate of the seepage within the drainage trenches, its sufficient capacity should not be provided with the trenches added to serve the drainage facilities. Alright, pipes for drainage blankets and filth. Normally perforated wall pipes with metal with plastic pervious wall concrete pipes. For the collector pipe, circular perforation should be general with no more than 3/8 of an inch. Filler material must be graded in accordance with the above guidelines. Pipers should be checked for the strength of the certain deep buried pipes may need to be cradled. Check for the corrosiveness and soil add in water. Certain metal pipes may not be appropriate. Soil soot and soil mitigation may occur with even the best design system instead of the clean-out points, so the entire system can be flushed and snaked. Well point and system deep wells. Alright, your methods. Excavation below with the groundwater soil add with the permitted with greater than 10 to the negative third foot per minute, with the generally required the dewatering permitted construction in the dry. For materials permitted between 10 and the negative third to 10 and the negative 5 foot per feet per minute, with the amount of the sheep small with the piezometric level that may be needed lowered in order to stabilize the slope. Prevent softening of the subgrade is drawn. Intermediate depth is normally accomplished with well point systems or sumps. Deep drainage methods include the deep pumping well, the reef well, the deep sheeted sumps. These are appropriate when the excavation exceeds the depth of the deep dewatered efficiently by the well point system alone, with the principal source of the seepage is from lower permeable strata. It shows a interceptor drain with a fill in the original grade with a transverse drain with a blanket. Original grade interceptor drain base of the subgrade. Intercepting drainage roadway on slopes. And then shows a picture, a chart of figure 9 is the rate of seepage into the drainage trench. And then skips another page. And it goes on to 511, construction controls. For important construction, dewatering installed with the piezometer below the base of the excavation, behind the slope of the coffer dam with the check with the performance adequacy of the drainage system, settlements effective the dewatering load of the water level of the permeable strata with adjacent to the compressible soil of the settlement may result. Well points consist of 1.5 inch to 2 inch diameter pipe with the perforated bottom of the section protected by a screen within the jet place with a prepared hole connected by a head wire by suction pumps. Accability well points depending on the water flowing with the gravity well with a screen with the belt pumping the with the grade of the drainage with the generally with not effective when the average effective with the grain size of the soil with the D10 is less than 5/100 of the millimeter with a very laminated soil with a silty fine grade with a separated with the clay soil with the glide or clay gravity drainage may be effective if an average material has much as 50% smaller than 5/100 of a millimeter. Compressible fine grained materials containing the effective grain size with less than 1/100 of a millimeter can be drained by providing a vacuum seal of the ground surface around with the well point with utilizing atmospheric pressure for the consolidation force, C section 4 limitations due to the iron and carbonated clogging. Capacity wells points ordinarily produce the draw point between 15 to 18 feet below the center of the header. The greater the draw point down with the install of the well points, except for the tiers and stage of the excavation proceed with the discharge capacity is generally 15 to 30 gallons per minute per point. Points are spaced between 3 to 10 feet apart with the finely stratified with the verified varved materials and minimum spacing points increase the effectiveness of placing sand angular space surrounding the wet point. Analysts. Wet point spacing usually is close to the seepage pattern, but essentially with a two-dimensional analysis of the total flow with the drawdown with the flow net procedure. Refine sand with the coarser material with the quantity of the water with the remove of the control of the well point layout. For silty soil with the quantity pumped with the relatively small with the number of the small spacing well points will be influenced by the time available to accomplish necessary drawdown sums. For construction convenience with the whole of the handle of the large flow with the previous soils that can be excavated with a solid or soldier beam. Horizontal wood lagging collected with the seepage to remove the central fecal pump placed within the sump, analyzing the drawdown flow quantity with the approximating the sump with equivalent circular well of the large for the diameter. Sheeted sumps are frequently used. Unheated sumps unsheeted sumps are far more common than unused in primary dewatering of shallow excavation and coarse sands, clean gravels, and rock. Electroosmosis. The specialized electroosmosis. Specialized procedure to utilize silts and clay that have too fine gravel that effectively drain with the gravity and the vacuum methods. Pumping well. The wells are formed with the drilling a hole sufficient diameter that accommodated with a pump column with a filter with the install of the well casing, placing the filter material with the angular space surrounding with the casing pumps will either the turbine type of the motor with the strip of the pipe column with the pipe balls hung inside of the well with a submersible pump placed between within the well casing. Application of the deep pumping wells are used if the dewatering installation must be kept outside of the excavation area. The large quantity to be pumped for the full construction period of the pumping must commence before excavation to obtain the necessary time for drawdown. See Figure 10 with the bottom pane with the reference down with the analysis of the groundwater lowing adjacent with the open water by every for analysis of the drawdown pumping quantity with a single well with the group wells of the circular pattern deep. The wells may be used with the gravels with salt, filthy sand, water-bearing rocks. Board shell wells and suction pumps can be used to replace well points where pumping is and require the shovel amongst the silty soil where correcting filtering is critical. Alright, special method. Ejector and adductor pumps might be utilized with well points to lift up to about 60 feet with the ejector pump with the nozzle green arrangement of the bottom with the two small diameter rise pipe with the remove of the water with the venturi principle. They are used in lieu of the multi-stage well point systems, and large pumping capacity of the deep wells is not required. The primary application for the sand with the proper control can also be used salt and silty and sandy silts. Alright, relief wells. The wells are in sand columns used to relieve water with the underlying strata that contain the artesian pressures and reduce uplift forces. Critical location relief wells may be tapped below the ground and collector system to reduce back of the pressure acting in the well. Application of relief well with the frequently used with the construction expeditions. The situation of horizontal damage course of the inadequate for the pressure relief of the deep foundations underlying with a varied stratified soil with the soils whose permeability increase with depth. Analysis. See Figure 11 for the analysis of the drawdown produce the line of the relief of the wells and board of the long dike that reduce the uplift pressure of the HM midway between the walls of the safe value of the very well diameter spacing penetration to obtain the best combination. And then it shows a picture of the groundwater lowering pumping wells. Space is blank, page is blank. And it shows another drainage artesian layer with a line of relief in the charts. Alright, 6. Laying of the reservoir with a pollution control facility. The purpose of lines are used to reduce the water loss with the piping, minimize the seepage which can cause the instability in the bank, but keep the pollutant with the mitigating with the groundwater surface, the holding pond with the seepage water treatment in the chemical facility with the sanitary landfills. Types, the table to-do list for the type of linings appropriate with the wave forces that are insignificant erosive forces that are present with the combined lining with a slope protection procedure. Sub-drainage in the water level of the reservoir may be below with the surrounding groundwater level. The permanent sub-draining system should be provided below the lining. Investigation for the line. Check any potential line with a reaction with the pollutant. Synthetic rubber is subject to the attack with the hydrocarbons potential. Inspect the attack. Certain synthetic fabrics may be subject to the termite attack and the potential for the burrowing animals breaching in the lining. 7. Erosion control. General. The design of erosion control must consider the volume of the runoff of the precipitate with the runoff velocity of the amount of soil loss. Volume of the runoff. The volume of the runoff depends on the amount of the precipitation ground cover, the topographical guidance for the evaluation volume of the runoff. See reference 12 of the urban hydrology small watershed by soil with the conservation services. Alright, amount of soil loss. Soil loss could be estimated using the universal soil loss equation developed by the Soil Conservation Service. Alright, A is the computed soil loss per acre in tons is equal to the rainfall erosion X index times the soil erodible factor times the slope length factor and slope gradient factor. This shows your methods, buried plastic, and applicability procedures, which is impermeable reservoir linings. Alright, EI and L and S values should be detained with the local office to use of soil conservation certificate with the value of the made determined with the published from the data with only particular with the locality with the absence of such data and may be roughly estimated with the figure 12 after reference 13 erosion control highway construction of the highway research board. 72 investigation where erosions could be inspected during earthwork construction. On-site investigation should include field identification with the classification of both agricultural texture unified system, the sampling of the grain side of the distribution, Adberg limited laboratory classification to determine inside in place density. Surface erosion control, the type of the erosion control practice with table 3 with the modified reference 13, general consideration to reduce the erosion must include construction scheduling construction avoid seasons of the heavy rains, winds or seasonal but negligible impact with the compacted water erosion. Soil type to avoid to minimize the exposure to highly erodible soil, stand easily with eroded by easily the trap. Clays are most erosion resistant, but once eroded are more difficult to trap. Slope length with a steepness for the reduce the slope length with a steepness for the reduced velocity that provide benches for the slope with the maximum vertical intervals of 30 feet. Your cover quickly with the vegetation such as grass, the shrub, and tree with other coverage with the mulch, straws, mulch applied to 2 tons of acres may reduce soil losses at much as 98% of the general slope. The other mulches inside include asphalt emulsion with a papered product with dew cloth, straw, wood chips, sawdust, netting of various nature. Man-made fibers, in some cases gravel. The soil surface range of the perpendicular flow, loose soil provided with a greater infiltration. Exposed area with a minimum of the area open at one time. Retain as much natural vegetation as possible. Leave vegetation also perimeters for the control of erosion act of the sediment trap. Diversion minimize flow of the dispersed and distributed area with the placing of the berm at the top of the disturbed slope. Sprinkling. Control depth of the sprinkling of the areas. Expose the sediment basin. Control debris basin to trap basin silt before entries into the stream. Channel lines. Table 4 prevents the guideline with the minimizing erosion of the earth and channel with the grass is covered with the channel with a modified reference 14. Minimizing erosion in urban areas by Soil Conservation Services. That shows a chart of your nanographs determining soil erodibility for universal soil loss equation. A table with typical erosion control practices, and then that's continued. Still continued. Continue a little bit more. I'm sorry I'm not reading these charts. I just they look pretty small. Alright, sediment control. Typical sediment control practices include with the table 3 with the traps. Table 4 limiting below with the velocity minimize erosion. Traps are small and temporarily usually created with the excavating and or diking the maximal height of the level of 5 feet. Traps should be clean perpendicular upon size of the outer structure that simple the design storm. Size of the pond length, width of the depth, remove the desired percentage of the sediment. See figure 13, modify the reference 15 with the trap efficiency reservoir by the Brune. For design criteria for interior, the reference 16 with the reserve sediment with a gas chalk. If the pond is permanent with the compute the volume of the anticipated average annual sedimentation of the universal soil equation, multiply the number of the year of the volume between the pond cleaning with the factor of safety that equals minimize the required volume of the bottom below the water level. The dimension of the pond will maybe calculated based on the available area with the design depth of the pond should be approximately 3 to 5 feet with the greater than calculated depth of the sediment at the time of the clearing. Riprap protection, frequently covered with the rock placed within embankments where the erodible soils must be protected with the fast current, with the wave of action, with the coarse rock, with the U, with the current wave that may be to wash soil with the under the rock and lead undermining failure of the soil loss with the under rock full of slope that can be prevented with the UV of the filter fabrics or by placement of the filter flat layer with the intermediate side of the material with the trim of the soil with the rock. In some cases, the soil loss would be prevented by use well grade rock containing suitable fine with which for the work of the bottom during replacement. Further, the guidance for see the reference 17 tentative design procedure for the riprap line channel with the highway research board with the determine the rock side with the filter requirements for use figure 14, reference 18, the design of small dams by Bureau Reclamation. And then it shows another picture of the capacity sediment control ponds. And then examples of calculations. Another picture of another chart of design criteria, riprap, and filtering earth embankments. Alright, filter may not be required for the embankment that consists of CL and ACH, and with LL 30 resistant surface erosion filter is usually the case for the ordinarily meet the filter criteria against the riprap only. Embankment that consists of non-plastic soil filters or seepage will move. Embankment low water 2 filters layers be required in small shell meet with the filter criteria again for the both embankment and riprap, and then show the minimum thickness of single layer filters are as follows. The double filter layers should be at least 6 inches thick and a maximum wave feet, and the filter thickness in inches. Alright, 8 is references, and then it continues, and then it goes into a final exam, and then the final exam is 35 questions, and that is your complete. It is a reading without the charts of the introduction, Seepage and Drainage by testing.